A pressure transmitter can pass an approved sample test and still fail the pump control application when production units arrive with a different range, output, cable, connection, or revision. In a water pump system, a near-match device may fit the catalog description while changing controller scaling, loop behavior, sealing performance, or the practical limits of installation and service. Volume release begins by defining exactly what was approved. The controlled configuration must identify the model, pressure range, pressure reference, output, supply voltage, process connection, cable or connector, enclosure rating, label, drawing, and revision. It must also record the conditions surrounding the device: the medium, seal, temperature exposure, cable route, cabinet entry, controller terminal, and mounting arrangement. These are not secondary details. They determine whether the transmitter that reaches the field is functionally and mechanically equivalent to the unit that was tested. The first release gate is configuration identity. The approved sample and the intended production unit must match by part number, configured range, output, supply, process connection, cable, label, drawing, and revision. The purchase order, supplier confirmation, approved drawing, and incoming inspection record should all describe the same build without unresolved alternatives. Next comes pressure range and output validation. Zero, span, and representative intermediate points should be checked against a calibrated reference. For a current output transmitter, the signal must be measured not only at the instrument but also at the controller input. Supply conditions, input load, scaling, wiring, and software filtering can all affect the value used to control the pump. A quiet test bench can reveal calibration issues, but it cannot prove that the installed control loop sees the correct pressure. Pump duty also introduces transient risk. A static pressure test alone does not establish resistance to water hammer or overload. Pump sequencing, valve behavior, pipe layout, sensor location, and previous transient history should be reviewed against the approved operating, overload, and burst boundaries. Before testing, the team should define acceptable post-test drift, leak condition, output behavior, and inspection requirements. A pass result without a clear measurement method cannot be applied consistently to incoming inspection or a later supplier change. The transmitter must then be evaluated in the VFD cabinet environment where it will operate. Confirm the power supply reference, loop load, analog input, wire routing, shield approach, terminal tightness, and controller value stability with the drive active. Electrical interference may originate outside the transmitter, so realistic VFD switching, or an equivalent documented simulation, is essential. The release record should capture both the wiring arrangement and the resulting controller trend. Environmental review must address the complete assembly. Temperature range, pressure medium, sealing material, enclosure rating, cable entry, cleaning exposure, orientation, condensation path, and mating components all contribute to real protection in service. An enclosure rating is meaningful only when the connector and cable arrangement preserve the intended boundary. Mechanical verification confirms the process connection, mating port, seal, torque instruction, mounting orientation, cable clearance, and maintenance access. A transmitter may meet electrical requirements and still create leakage, replacement difficulty, or unsafe service work if these interfaces are not controlled. Design, assembly, and service personnel should confirm that an approved replacement can be identified, installed, and connected without changing pipework or cable routing. Once the sample is approved, production consistency becomes the central concern. Lot identification, incoming inspection requirements, inspection or calibration documentation where appropriate, and written change notification create the traceability needed to compare a field unit with the approved configuration. Incoming checks should focus on characteristics that can alter fit or function: identity, label, output behavior, range, connection, cable, and visible enclosure condition. The final release gate combines the evidence into one controlled record. It should include the approved configuration, drawings, test results, controller settings, installation assumptions, acceptance criteria, approved deviations, and change notification rules. Engineering confirms application fit. Quality confirms conformance evidence. Purchasing controls the order description. Production and service confirm installation and replacement practicality. Volume release is not a general approval of a transmitter family. It is a controlled decision that confirms the production batch will match the tested configuration, the installed system, and the conditions that justified approval.